Hi friends, welcome to the Power DSP lessons. Today we are going to see an important topic called convolution. Convolution is one of the most important technique that we find in digital signal processing. So we need to understand the concept behind the convolution very clearly. To understand convolution, we need to know what is a linear system and what is an impulse response. Let's see that first and then move on to see the convolution. What is a linear system? A system is said to be linear if it satisfies some important mathematical properties. The first one is the scaling property. If there is any change in the input signal's amplitude, then the corresponding change should replicate at the output. If the input x of n produces the output y of n, then the input a x of n should produce a y of n at the output. The second property need to be satisfied by any linear system is additivity property. If an input x1 of n produces the output y1 of n and a different input x2 of n produces the different output y2 of n, then the system must produce the output y1 of n plus y2 of n for the input x1 of n plus x2 of n. By combining the scaling and additivity property, we can form the superposition principle which is given here. The third important property is called shift invariant property. Any shift at the input should produce the identical shift at the output. So we can tell the system is linear only when if it satisfies these properties. Next, we need to understand what is an unit impulse and impulse response. Unit impulse is a signal which has a value of 1 at the sample number 0. Then impulse response is the response of the system for the unit impulse input. Okay, next we see what is convolution. Let's take a system and the task here is to find the output for any particular input x of n. How can we find the output? Obviously, we have to connect a CRO to measure the output. We also have to have the clear understanding of the internal components of the system. On the other hand, if we know the impulse response, we can find the output very easily by just convolving the input to the impulse response by not needing to know much about the system. Moreover, we can find the output for any input if the impulse response of the system is known. So the concept is very simple. If we know the impulse response of the linear system, then we can find the output for any possible input. Next, we will understand this concept with an example. Let's take an input x of n as 4 samples 1, 2, minus 1 and 3. Impulse response with 3 samples 2, 1 and minus 1. We need to find the output for this input x of n. Next, what we are gonna do here is to send only one sample at a time instead of all the samples. This is usually called impulse decomposition. We are taking the first sample here, that is at n is equal to 0, amplitude value of 1. This is nothing but unit impulse. If the unit impulse is the input, then impulse response h of n is the output. We know that. Next, we are taking the second sample which has the value of 2 at the sample number n is equal to 1. We can write this sample in terms of scaled and shifted version of unit impulse. Amplitude is 2, so the unit impulse is scaled by 2 and the sample is shifted one sample from n is equal to 0. So the unit impulse is shifted by minus 1. Now the sample is written in terms of scaled and shifted version of the unit impulse. What is the output now? Very simple. Apply the linear system property. The same amount of scaling and shifting should appear at the output. if the system is linear. So the same amount of scaling and shifting is appear at the output. Similarly, we can write the remaining samples in terms of scaled and shifted version of the unit impulse, and we can easily find the outputs using scaling and shift invariant property. Finally, if we add all the samples, we get our original x of n, and we can find the output y of n by adding all these outputs. Superposition principle. If x1 produces the output y1, x2 produces the output y2, x3 produces the output y3, x4 produces the output y4, then x1 plus x2 plus x3 plus x4, which is x of n, must produce the output y1 plus y2 plus y3 plus y4. This is equal to y of n, that is output. Even if we change the input, we can find the output by applying the same principle. So literally, we can find the output for any input. Okay guys, the concept is clear now. If we know the impulse response, then we can find the output for any possible input. Meet you soon in the next lesson. Until then, bye bye from P. Madan Mohan.